So how many questions are there? 18. Ugh.
Yep, 18.
Okay. Hey, shall we go?
Let's do it.
Recording, Cassie?
I remember this thing.
Okay. So number 1. Oh, I have nothing to hold my phone up with. Okay, except this Bible. Okay.
So number 3, I got C for the true population proportion.
Same.
B?
C.
Yeah.
Oh, C. Not
Wait.
P hat?
No, it's just a regular P.
Oh, yeah, because P hat is the sample proportion.
Yeah.
Okay. For the next 2 questions, suppose N is 100 and P equals 0.25 and P hat is 0.10 for construction and confidence level satisfied. So N times P have to be greater than 10.
Mm-hmm.
So
100 times 0.25.
hang on, I am so unorganized today.
0.25. So that does meet the first requirement.
It does. So
Yeah.
100.
Because I got 25.
Okay, and then it's N times 1 minus P.
Mm-hmm. So that would be 1.
So that's true, right? Or true?
Yeah.
Oh my gosh, this is driving me out of my mind. Sorry.
Okay.
I don't know how to do this. I'm just gonna hold it up. Okay, so requirement.
I have to charge my phone, so I'm sideways, and so that's why I turned my screen off.
Okay. Are the requirements for conducting a hypothesis test true? They are. The requirement for that is the same, but I'm going to party hard when this class is over.
Oh, I know.
Same.
Size, we always round up. So whole person. So even the 318.
Okay, so I'm trying to find the hypothesis test for. Okay. Okay, so the p-value.
We can also do this calculate.
The requirements for.
Bigger than 10, so we do meet those requirements.
Are the same, except
with a p-value of 0.187, then our conclusion would be that we fail to reject the.
Okay, the same. It goes the same requirements for a hypothesis test.
Okay, so that'd be true.
It's the same requirements. Perfect. They have to be greater than 10.
So study of first-degree murder trials were conducted in another state, a random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. So find p hat, the point estimate of the proportion of first-degree murder defendants who were found guilty in this state.
So on this one, I think you just divide 45 by 60.
Mm-hmm.
I think it's 0.75. Is that what you guys got?
Yep, that's what I got.
Okay, so create a 95% interval for the true proportion of first-degree murder trials in this state. There where the verdict is guilty. Input your answer for the margin of error. So let me see. I have a 2 sample TZ test up. We need a 1 sample, don't we?
I believe so, yeah. Let's see.
I don't. Go. Okay, so what is X is what? Meaning we're trying to find, okay, so we're trying to find the margin of error for a 95%.
So that would be 1.96.
I'm trying to do it on myself.
Oh, okay.
I think you put 45 in the top box, and then you put 60 in the second box, and 95%. I'm trying to find out.
Then
In the third box. Hypothesis test result requirements are 42 and 18. Confidence interval requirements are met. Okay, so p hat equals 0.75, which we got before.
mm-hmm.
I don't know what the margin what the margin of error is. Is the margin of error 60 minus 45 and then squared?
Is it the lower bound or the upper bound minus the lower bound divided by 2? Is that what you said?
Yeah, but we got to figure out what the upper and lower bound is first. So I have a confidence level is confidence interval. I think this is it. I think determine your margin of error. Okay, so 65 is the low and 86 is the high.
Oh, okay.
So I think so.
So the upper bound was what?
X.
Okay.
I think.
And then, so 86 minus 65.
So I think 86 minus 64, and then you think it's squared?
Cassie, do you know?
Where did the 86 and this, what was the other one come from?
It's on the Excel sheet.
Oh, okay.
Do you guys have that Excel sheet up
I'm in the
On your-
process of putting that up.
computers? Online. Okay. Okay, are you there yet?
Mine's downloading.
And then lesson 17, Cassie?
Yep.
And then online textbook. And then right where it says confidence intervals, it's actually under 2.3, using Excel to perform these calculations.
Mm-hmm.
You can link to it. The first one is the Excel.
Do you want the unit 1 file, 2 and 4, or 3?
The what?
Which unit? It says unit 1 file, units 2 and 4, or unit 3?
See that?
Oh, did I click a different link?
I'm looking in lesson 17,
Uh-huh.
and then under 2.3, it says using Excel to perform these calculations.
Yeah, I
And
see
it
what you
says,
Alexis.
Oh, you do?
did I download the wrong thing?
You may download the zip folder with all these files. Which file do we need?
Well, there's 3 on there. One says 1 proportion, one says 2 proportion, and one says square.
So what I have is I have unit 1 file. It says quantitative descriptive stats. I have units 2 and 4, which is interference procedures, and then unit 3, which is categorical data analysis.
I think it's categorical data analysis.
Okay, I have it.
Do you see on the Excel sheet where it says there's tabs at the bottom that says 1 proportion, 2 proportions,
Mm-hmm.
and then so if you click on 1 proportion,
Mm-hmm.
it says 1 sample z-test for proportion, and then you input your
Information.
information. But this says null hypothesis 0.70. I don't think we need that on this particular question anyway.
Okay, so we want what proportion?
What?
1 proportion?
Yeah.
Okay. Okay.
Oh. That can't be right, because if we only have 60 samples, how can the upper bound be 64?
So did you put in 45, then 60, then 0.95, and just take out the hypothesis?
Yes.
Okay, that's what I did too.
But I don't see where the upper bound and lower bound are.
So confidence interval, right down there in the
Yeah, but if your sample size is only 60, how the confidence interval? Oh, I don't know.
I feel like this should be more simple than SPSS. It's confusing me.
Watch the video that the teacher put out.
Yeah.
Did you guys watch that at
Mhm.
all?
Yeah.
Because I feel like it should be in there, but
This video, I was
let me see if I can.
work by hand. But in these chapters on proportions, there is a really awesome Excel spreadsheet that can help us do the calculations as well. And if you've been one of those SPSS haters, then you are going to love this Excel spreadsheet. So here's what the spreadsheet looks like. And basically, you need to input all of your information in the inputs box over here on the left. So I put in X, that's the number of successes. It's the number of accurately filled orders in this case. Put in my sample size N, and I put in my confidence level of 0.95. I wanted a 95% confidence level. The Excel spreadsheet will also check our conditions for us. So it does all that math for us. We just look here and make sure that both of those are bigger than 10, which they are. And then the confidence interval is going to be down there right at the bottom, 0.883 to 0.949. You can see this is exactly what we got when we calculated it by hand, just a lot faster and easier using this fun Excel spreadsheet.
That's the confidence level. It doesn't have anything to do with margin of error.
So the equation for margin of error, isn't it the top minus the bottom?
All right, so now
I don't know.
Yeah, I thought it was the top, the bottom divided by 2.
Oh, divided by 2?
Oh, wait, or is it squared?
Maybe it's,
But we need to find out, is it the margin of error? We have to find out the margin of error, how to get the upper and lower bounds of the margin of error before we can do anything else, I think. I mean, the upper and lower bound, I don't know. I hate this. I absolutely hate it.
wouldn't
I
that be
hate it with every.
is the upper and lower bound?
What do you think is the upper and lower bound?
0.64 and 0.86.
Where do you see that?
So under the one proportion test, there's a confidence interval, and it's 0.64, and the top one's 0.86.
Okay, so that null hypothesis doesn't mean anything. So you think 0.64 and 0.86?
86.
That's the only thing that I can think of.
We can try it. 0.64 is the lower one. 0.8. What was it? 86 is the upper one.
0.86. And then would that make the margin of error 0.11?
That's what I got when I calculated it.
Okay.
But
You think the margin of error is what?
0.11.
11.
0.11?
Mm-hmm.
Okay.
I hope it's divided by 2. I hope I'm not leading you guys astray.
No, I
I
think
think it is. me.
If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? Would it be increase?
Yeah. Wait.
Because there's more people, so more.
I think it would decrease, like it would be smaller, meaning, well, confidence.
Usually it goes the opposite direction. If you increase it, it decreases the confidence interval.
Yeah, that means there's a small margin of error, right?
Yeah. Okay, to conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest n can be, and both requirements still be met?
20.
Huh?
What was that?
20? What do you think it is?
Can it be 20?
That's what I said.
That makes sense to me.
But tired of holding this phone. You guys just have to listen to me and not see me. Okay, so n times p, so 20 times
0.5.
5 is 10, but it also has to be n, which is 1 minus p. Yeah, 20. Okay. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose that 1/10. What is the smallest n can be?
100.
100, isn't it?
Yeah.
Okay. For the water quality study and the reading, about 60% of the macro introvertible whatever water quality indicators have historically been good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using a significance level of 0.5. With the following hypotheses, P is 0.6 and P is less than 6, they collect new data, and this time N equals 80 and X equals 38, indicate good health. So is it satisfied? So you have to take N times
P.
0.60, and that's 48, or N times 1 minus 0.6, and that is 32. So yes.
Yep.
I got.
Okay, what is P? P hat. So that would be if N is 80 and X is 38, so it'd be 38 divided by 80, right?
$38 divided by 8?
Huh?
Did you say 38 divided by 8?
80.
Oh, 80.
Oh, I thought I said 8.
Or is it 80 divided by 38?
Well, isn't it one? Isn't it? Don't we use P?
Well, what is, oh,
So would it be P times 1 divided by 80 squared, all of that?
0.60 divided by 80?
So it's that P times 1 minus P divided by N squared. Is that the one we're looking for?
I thought P hat is P hat is the point estimate for P. So Okay, hang on. She just did this in her video. Let me look real quick. I don't know why I can't keep that going.
I got 0.055, if that's the one we're looking for.
Okay, just a second. It's right here in the beginning here.
And this, I'll describe how to do point estimate for P. That is just the sample proportion, calculated by taking the number of successes in the sample divided by the total number of observations. The confidence interval for P, I expect P hat, our sample proportion, to be to P population proportion. Formula for doing a confidence interval for P looks like this. We have P hat plus or minus square root of P hat.
Okay.
In this video, I will describe how to do inference.
So you think it's a 0.60 over 80 divided by 80?
So this is the, I'll try to show you oh, that's backwards. But
Okay, so hang on,
does that make sense?
So P equals, so P is 0.60, right? Times 1 minus 0.60. And then you divide that by N, which is 80. And you square that whole thing, right?
Yeah, that's what I thought. Completely
So
wrong.
0.0003
Squared.
square root of 0.0003. I got 0.017.
Did you do 0.003? Because it sounded like you said 3 0.
Oh, that's 4, isn't it? That's 4. Okay.
It was just 0.003.
So 0.055.
Yep, that's what I got.
That's what I thought.
Hopefully that's the right
Okay,
equation.
find it.
Just what I thought it was.
Okay, so let me go to Microsoft. Here, read me off the numbers. So x equals what?
38.
X 38. And n equals 80.
Yep.
And the confidence interval is, does it? But it says null hypothesis is 0.60, and we want to know if it's greater than or less than. Let's see.
If it's less than 6.
If it's less than,
Mm-hmm.
okay. So the p-value, I don't that's statistic. Let's see. Is the test statistic the p-value? No.
I think they're different because they ask for both.
Okay, the p-value is 0.011.
Where's that?
That's number 6. Huh?
Where do you see that?
I put it in the Excel thing.
Oh, okay. So 0.011.
Mm-hmm.
And it says the t-test, is that the z? Is that z? I don't know. I don't see anything that says the t-test like we did in the SPSS. So if you guys go to the Excel sheet
Mm-hmm.
and you input 58 for X, 80 for N, confidence level 95, null hypothesis is 0.60, and the type of test is less than.
What was X?
It's in the question right there. See question number 13 just above it. It says X equals 38.
Oh, God.
Oh, so the p-value is 0.011.
Yeah, but I don't know what the test statistics is. Is that the
That be
Yeah, I'm not really seeing it.
you don't see it? What do you mean you don't see it? You don't see it on the Excel sheet?
No. I have the Excel sheet all in. I just can't find the test statistic.
You see that?
Yeah, because that's what I have.
But I don't know what the test statistic is. Is that the Z-score?
Aren't those different things, though?
I don't know. So how do we find out the test statistic?
standard deviation of the hypothesis test. That's not it.
Oh gosh, I don't know.
Confidence intervals. When we use the confidence interval, conservative estimate for P star is 2% or 0.5. So in this case, we're going to start with that 75% there. And again, everything that goes into our formula must be in decimal form. So I'm going to use 0.75 in those calculations.
Okay, so we're doing
317 arm of
I don't know. I wish I was in a better mood because right now I don't even care.
Right? I'm done.
Z-score is it? So negative 2.282. What I'm putting. So I'm guessing that if it's less than 60%, we keep the guy. So I'm going to guess fail to reject the null hypothesis.
I have a question. So back to the p-hat question.
Mm-hmm.
In the Excel sheet, it says p-hat is 0.475, but we put 0.055.
Okay, because we did it by hand.
Yeah, so should we change that?
I will, yeah.
Where does it say that?
In the Excel sheet, it says p-hat, it says 0.475.
Oh.
So it'd be 0.48. Oh, I guess we would put 3 decimals. Never mind. Yeah, so 0.75.
Okay, I'm turning this thing in because I'm so tired right now.
What did you put for 18?
I put there's sufficient evidence to conclude that water quality in the area has decreased. So I'm submitting this and I'll let you know because, okay, so we got number 3 right, 4 right, 5 right, 6 correct, 7 correct, 8 correct, 9 correct, 2 correct, 11 is correct, 12 is correct, 13 is correct, 14 is correct. We only missed 1.
Was it 15?
We missed 17.
17?
17 is reject the null hypothesis. Everything else we got right.
So was 18, was it B or D?
D.
Okay. Wow, so the test statistic question was right then.
So it's the Z.
It must be the z-score.
It's good to know.
Anything of it would be good to know. Any of this crap would be good to know.
I know.
All right.
So let's just go through so you guys can get 100% your first tries. 3 is C.
Wait, hold on 1 second. Sorry. My thing just freaked out. That was so weird. It like logged me out. It's logged me too long. All right. Sorry.
Are you ready now?
Yes. So 3
Yes.
is C, you said?
4 is true. 5 is true. 6 is 0.75. We actually did really, really well. I'm surprised.
I know.
7 is 0.11. 8 is 0.64. 9 is 0.86. 10 is A. 11 is 20. 12 is 100. 13 is true. 14 is 0.475. I'm glad you caught that, Alexis. 15 is negative 2.282. 16 is 0.011. 17 is A. 18 is D.
Perfect. Okay. Wow, guys, we did good.
I can't believe it because I'm telling you, I'm about so done. I don't know if it's just today or the last couple of times have been so frustrating for me, but like I'm really, really over this.
Same.
Okay.
But it could just be the day in the week. Who knows?
I know.
I mean, I love having the Excel sheets, which
That was
helps out,
nice. Yeah.
but it took me forever to figure out how to download it. So I think my problem with all of this is it's not just learning how to do the problems, it's learning how to do the software as well.
Yeah, the software is the hardest part for me because I hate technology.
Yeah, I'm not so good at it. So learning the technology is just, hey, what was number 7? What did I tell you number 7 was?
Hold on.
Did I say 0.11?
Isn't it? Wait.
Sorry, I'm trying to get back to it. Okay, 7 is 0.11.
Okay. And then number 16 is 0.011.
Yeah.
All right. All right. Well, we have a couple days break from all this. I'm going to take a couple days break from it anyway.
I know. I'm right there with you. I need a break from math.
Yeah.
And I think we have a quiz at the end of, I mean, not a quiz, a test at the end of the month, which I'm not excited for.
Don't we have 2 more tests. We have a test and a final.
Yeah.
Yep.
So, yeah, I don't know. All right. Well, have fun in Ohio.
Thank you.
That is awesome.
I'm stoked.
All right. I'll see you guys on Monday.
See you guys later.
Yeah.
Monday. Bye.